NASA successfully transmitted messages using laser technology across 16 million kilometers. That's about 40 times farther than the distance from Earth to the Moon. This is the first time optical communications have been successfully sent over such a vast distance. The successful test was facilitated by NASA's Deep Space Optical Communications tool aboard the Psyche spacecraft, which was launched from Florida on October 13, 2023. The spacecraft, on its journey to explore the metallic asteroid Psyche, established a link with the Hale telescope in California on November 14th, using near-infrared photons for communication, which took approximately 50 seconds to travel from Psyche to Earth. The technology could eventually allow us to send and receive high-definition video messages to and from Mars without annoying delays. It could also revolutionize communication by enabling the transfer of information 10 to 100 times faster than current technology. However, laser technology brings some interesting challenges. For instance, data bits are encoded in the emitted photons, requiring some heavy-duty instruments to prep and translate the information for transmission. Plus, there's the real-time positioning challenge, where the system needs to adapt to ensure successful communication over such long distances in outer space. Even though there's more work to be done, this achievement sets the stage for some pretty exciting possibilities in space communication.
Placing a spaceborne umbrella in orbit could help combat the effects of global warming, according to a group of scientists who recently proposed the idea. This umbrella will be positioned in orbit between the Sun and Earth to block or reflect harmful UV rays, potentially mitigating the effects of climate change and regulating Earth's temperature. This isn't the first time space-based sun shields like mirrors or shades have been proposed for preventing climate change. However, scientists have struggled to design a shield that effectively balances weight and costs until now. One potential solution to the weight problem involves tethering the solar shield to a counterweight filled with asteroid material using a strong graphene tether. The counterweight would slowly open once in space, allowing it to gradually fill with lunar dust or asteroid material that would act as ballast. Since the ballast would be captured in space, launching it from Earth would not be necessary. The shield and counterweight would weigh around 318 million metric tons, 100 times less than untethered designs. The shield itself, which is the part that would need to be launched into space, would only account for 1% of the total weight. Although this concept offers a potential solution, it is met with skepticism from some scientists due to uncertainties associated with large-scale geoengineering, high costs, technical complexities, ecological risks, and ethical concerns. Back when the universe was around 1 billion years old, time seemed to move 5 times slower compared to the present day. This effect was identified by astronomers studying powerful black holes at the center of galaxies, known as quasars. The research involved analyzing data from 190 quasars over 2 decades. The findings support Albert Einstein's theory of relativity, confirming that the distant universe experienced a slower time. Previously, scientists observed bright exploding stars called supernovas to understand how time passed in the past. They found that time moved at half the speed when the universe was younger, but now, with quasars, they've seen that it was even slower by 5 times. Researchers explained that even though things looked slower back then, if we could go there with a stopwatch, time would still be normal. 1 second would still be 1 second. Quasars are the brightest objects in the universe and are valuable tools for understanding cosmic evolution. Accurately dating ancient quasars could also be useful for further exploring the nature of dark energy, the mysterious force thought to be responsible for the surprising acceleration of the universe's expansion. Quasars emit incredibly intense radiation across the entire electromagnetic spectrum, from radio waves to gamma rays. Quasars' luminosity is so immense that they can outshine entire galaxies, despite often being located billions of light years away.